Hi, this is your host Swapnil Bhartiya, and welcome to another episode of TFiR Let's Talk. And today we have with us David Hustace, CEO and founder of the OpenNMS Group. David, it's great to have you on the show.
Thank you. Looking forward to it. Yeah.
Yeah, we have covered the group in our news stories, but this is the first time kind of we are talking to each other. So I would love to know a bit about the history and story of the company and group as well, because you are also the founder. So talk about, what problem you saw in the space that you felt compelled to create this group.
I'm actually one of three original founders. What was interesting about the challenge we found with network monitoring, and this is 22 years ago. So, the co-founders really worked in a space where we were delivering solutions to some of the biggest global internet service providers in the world, and then we had the 2001 kind of dot bomb, right? So at that point in time, there was not a lot of money in budgets for capital budgets or even for software licensing and this kind of thing. And so there was someone who had started an open source project. It became OpenNMS, and they were VC backed, and they had brought in one of my partners, one of my original co-founders, and he got involved in the open source project, started getting me excited about it. And then at one point, the investors in that business were struggling with finding a way for open source to be a viable business. And so he left and took over maintainership of the project, and they went and closed the source and went off and did something else with the intellectual property even, right? So we took off and we started building a business around delivering solutions that we would normally have done with commercial software with open source software. And what we found was, we thought, well, we can do this for small and medium-sized businesses because everybody is getting pulled into the internet economy. They're probably going to struggle with some of the things that they would normally not be looking at facing with paying license fees and things like this. And our first customer out the gate was a GE corporate, and they were rolling out their very first MPLS global internet backbone. They came to us because they went to enterprise IT for monitoring, and the monitoring solution was going to be more expensive for licenses than the cost of rolling out the infrastructure. So we really found ourselves in a unique position because of the way OpenNMS was initially designed, was to be an enterprise scale application. And the way we created our business was really around services around the open source software.
Thanks for kind of sharing the history. Story.
Yeah.
Since we're talking about network monitoring, I also want to kind of for our audience, so they do understand, because when we talk about network in general, and especially in today's cloud-centric world, it could mean so many. We can go all the way to talk about those cellular connectivity network, or we can also talk about network within the compute cloud space. So when you talk about network, which network are we talking about, or there is no differentiation? It's just different use cases.
Yeah. So that definition of the network has changed a lot from the time we started. From physical. There weren't even like smart switches, and like hubs and routers and the technologies that were used then were T1 lines and point-to-point connections, and then public networks came in with frame relay, and so getting an idea of what an actual shared network infrastructure looked like came in with frame relay. And then MPLS backbones became popular, and now we're seeing SD-WAN and a lot of things coming into the marketplace that really change the way networking is technically done. But at the end of the day, we're still making connections for applications to communicate with each other across the network. As software-defined networking is also another interesting aspect to what has changed, and where the logic and understanding of topology is stored in some central place, like in a cloud or SDN service, and when you're monitoring, you're no longer talking directly to the devices, you're talking to a controller. And so we've seen that model change as well. And so fortunately, OpenNMS model is very adaptable. And so we try to normalize those ecosystems into the platform, whether it's a software-defined network or a virtual network, VPNs, or whether it's physical networks. It's all network technology for us, and we try to make that normalized into a network-centric view.
The company actually predates, it was 2004, right? Kubernetes and everything came back in 2014, and all those cloud, I mean, they are so new compared to what you folks have been doing, but market has changed
Yeah.
dramatically. I mean, we started talking about software-defined network, ages ago, and there were a lot of open network, and there are a lot of Linux Foundation projects are there. Apache has a lot of projects there. So if I ask you, of course, then there are hardware company like NVIDIA, SmartNICs, and everything is coming in. VMware is doing a lot of work in that space. How, I mean, you did touch upon that, but if I understand from you that, how has the network space evolved? Plus, today, users, when they do talk about we move to cloud, but we still have to worry about all the complexity that come with it. We talk about security, zero trust security network is there. So talk about how the landscape has changed over the time, how the complexity has increased, and then we'll talk about how OpenNMS, how you folks are actually
Yeah.
trying to help, users. Yeah.
Yeah. Well, it is interesting how you're still trying to solve the same problems. It's just the landscape has changed, and one of the things that's been interesting about OpenNMS, and probably one of the great advantages of being an open source project, is that we've been able to stay technology fresh. And so the technology within OpenNMS, as well as the technologies that we're monitoring, and as it's evolving, what we're seeing is that like the infrastructure around, like it used to be like we would even burn CDs when we would go to conferences, like here you go, here's the software, and then all the copyleft stuff with respect to open source was like, if I give you a CD, I also have to make sure I give you a copy of the source code or make it available for a certain amount of time, and all those things is like, but all that changes when you think about how software is distributed today, whether it's Docker Hub or we don't even have. We have Yum repos today where people still download and install on platforms, but all that is changing. So even the infrastructure of our software has to adapt. And so one of the things that we're doing now is we're taking the technology that we have and we're building it around a Kubernetes-based microservice architecture. Now that helps us to do a lot of things, also to be able to reach into environments and be deployed into environments where it's not necessarily where you take a monolithic app anymore. So an orchestrated environment, with an operator model, whether it's a private on-prem cloud or whether it's a deployment into a public cloud infrastructure. And then we're also using that technology to build our own service that we're building a SaaS solution to make adopting monitoring easier for the user, right? So, our vision statement now is OpenNMS, we're creating a vision where monitoring just happens, right? So we're using kind of an appliance technology, whether it's deployed as a hardware appliance or as a virtual technology. And you can deploy those things into the edges of your network and then still take advantage of a very secure and what we call a secure data pipeline back into the SaaS application, and then still have the same core essence of what made OpenNMS strong in all the environments as being a platform. So once the data gets into our SaaS solution, we still make those APIs available, either traditional APIs with REST or streaming APIs on the data pipeline.
I love, the way you said you kind of try to stay, I think, if I'm quoting it wrong, technology fresh or something, but the thing is, as you're using these technologies, you also, I'm pretty sure in some cases, also use them as, see them as use
Right.
cases where a lot of users are coming there. So I'm also kind of curious about, of course, you can share the names or not. That, of course, depends on the NDAs and all those things. But I would love to understand a bit about the use cases or users who are leveraging, OpenNMS. And we can kind of go all the way back as you started, from the beginning. And today in the cloud-centric, cloud-native, API-driven world. So talk about the users there.
Yeah, so OpenNMS really tends to be, and if I think about the company for just a second, generally, when we engage with another company that's interested in using OpenNMS, we're talking with a solution architect. somebody who's looking to bring a monitoring system in that they can integrate with the rest of their business. And because, at least two of the founders, one of the founders was, what I would call a rock star software engineer. Two of us were system integrators, hackers in our own right. And what we would do is we would bring solutions to customers using network management software. But what we found was the inflexibility of the solution when it wasn't open source. And then even if you had APIs for those things, you just have the documentation of the API, and you would often well, it's not behaving the way the documentation says. And when you have an open source solution, it's not behaving the way that the documentation says. You can just look at the code and you go, oh, well, this is what it's actually mean. This is what it's supposed to do. And then you can either submit a patch or you just use it the way the code functions. Well, those solution architects generally, and what you'll find OpenNMS, at least with the customers and the users that we've worked with over the last, it's hard for me to say, 18 years now, right, are some of the biggest companies in the world. I mean, and the biggest companies in the world. I without naming names, you could just imagine, and these are companies that could literally afford anything. Right? So being open source and maybe being a low cost model or whatever really isn't what drives them there. It's about the ability to take the solution and craft it into something that actually delivers something that works with a business versus the other way around. And so that's what I've found to be fascinating is the time is where we contact or connect with the community are usually people who are solution architects, somebody who's trying to bring something in that integrates with the rest of the business. And we find ourselves, in situations where we worked really hard to make this monolithic application hyper scalable, really hard, which was becomes a little bit of a problem because when you take in, a multi-threaded asynchronous application and then try to make that into a microservice-based application, you've just you're taking, it's a completely different way of thinking, right? And so that's one of the challenges that our CTO faces now is how we're actually breaking that up into microservice-based application. But when you go to any of our customers, I guess I digressed there a little bit, was you'll find if you say, talk to me about monitoring, the first thing they'll do is go to the whiteboard, they'll draw a circle and they put OpenNMS in the middle, and then it feeds so many other things. Now, that kind of takes it out of the limelight because people aren't necessarily using or exercising the UI, maybe the dashboards and the Grafana plugins and things like that. But it's really what feeds all the entire ecosystem for monitoring. And that's what we want to do with our pivot to the SaaS application, is be able to do that same thing, but not require companies to have to build such a complex set of infrastructure just for monitoring. They can just exercise the APIs and let us worry about running and hosting all that infrastructure.
When we talk about network monitoring itself, once again, how have you seen the monitoring itself kind of change? Because in today, I'm trying to build a lot of correlation with the cloud native where we talk about observability and the things are all logging. So once again, because of the use cases have evolved, how have you seen the evolution of network monitoring itself? What are you seeing the changes there, and how has the project evolved, modernized to keep up with that?
Yeah. So what we've done is a lot of the monitoring has changed a lot, right? And you used the O word, I heard, the observability word, right? And there's an awful lot of so for me, monitoring is can I monitor that? Well, is there instrumentation, right? Right. And so observability is just another way of providing instrumentation in an application or in some infrastructure to be able to provide that data to a system that can gather it and collect it and present it, analyze it, and either produce faults or performance or even trends and analysis and those kinds of things. So what is really interesting to me is that in the networking space, where the simple network management protocol was drafted and created with, hundreds of RFCs out there for specifying how monitoring would be done in the network, it's still out there, right? It's like somebody builds an amplifier on a fiber optic network, and they sell it to, say, a large service communication service provider, they say, well, we need SNMP. So even these modern day, very advanced technologies are still, for the network monitoring piece, are still just saying, well, just give me SNMP, because everything I have can communicate with that. And I think it's because it really is a lot of credit to the time and effort that the crafters of that specification put into it. Everything from the protocol to the data formats and structures, and how it's serialized and deserialized on the network, and how it's represented in schemas and things. The whole specification end to end was written. And today we're like, well, we got a REST API. Well, what's inside there? What do I do with that data? And so, but what has happened is, I think technologies have adapted that. Just send me a pile of JSON data. We'll throw it in Elastic or Splunk, and we'll just figure it out then, right? So I think observability kind of got pushed that direction, because you have these, very complex storage technologies that are indexing that data like crazy, and you can build queries and find things. I think where we find, the challenges are, even with these, more advanced, so to speak, technologies, is it's hard to scale them, because they require dedicated connections. Right, so you nail up a connection, and now you stream data in. And what do I do? It's a TCP session, and it's, like 5 or 6 handshakes to get a connection up and going. You got to keep it going. You got to keep it alive. Whereas with UDP, it's, you throw it out there, right? And the network handles it, right? And then it's very asynchronous friendly. And so it really does allow it to scale. So there are challenges, but again, technology has grown to meet those challenges.
I also want to talk about some of the new. I mean, this is not a new use case, a new word, but I like, like you network folks, you folks like your acronyms, but other thing, we have observability and all those long notes. I want to talk about edge computing. Now, when I'm talking edge computing, I'm not talking about like small IoT devices, but edge data centers, which it could be. So how does that look like from network monitoring perspective? Plus, we're also seeing the adoption of 5G private network going. I'm not talking about the 5G carriers, but private network. How does that look like from network monitoring perspective? If you can share any insights there, it'd be great.
What's really interesting is that so first I'll take how things are changing with respect to, I think, the edge computing. So, there's a lot of definitions of edge computing out there, everything from taking cloud technology and running it at the edge, and, like you've pulled that technology down, and there's a lot of challenges there. But the way I've seen this is that where we used to spend a lot of time monitoring in the core of the network grew. And what we're seeing now is the core of the network is really shrinking, and most of the network is getting pushed out to the edge. And so all the connectivity is really on the edge, and I would think that was the big SDN hit, was SD-WAN, right? So now, instead of having dedicated connections, now you're using SD-WAN and internet connections, but it's probably the same provider, right? It's now an internet connection and not a metro connection or something, right? Not metro Ethernet or whatever. But I think that yeah, what we've seen is that it really is getting pushed to the edge. And for us, what we're looking at is we've really worked hard on an edge technology, and we call that friendly name is the Minion technology, and we call it Minion because it's stateless piece of technology that you deploy, and being stateless makes it really easy to manage, right? If it dies, you just start it again, right? Very friendly to Kubernetes environments and things like that. We also are building in a security aspect to it by using hardware. We'll use the onboard TPM chips to build a zero trust architecture from the remote edge all the way into the cloud. And one of the things that we think we offer there is not only being able to securely communicate with the edge from the cloud, which is a challenge, right? It's like, how do you allow a cloud application to come into your remote areas of your network when usually that's all private address space and usually a highly secure environment? What you want is something on the inside that is communicating out, right? So that's what we've done is with the Minion technologies, built this stateless component that we can run as a virtual process or within hardware. And within the hardware solution, we really can lock it down with security, right? Using all the connectivity back into the IoT infrastructure in the cloud is all locked down with a certificate that we generate from the onboard TPM chip, and then we also are able to encrypt on disk. So anything that we're caching and then writing out the disk, if there was a communication concern or issue with, we can store on disk, and then when the connection comes back up, it goes to the cloud, and we don't end up with problems where we have just raw data sitting on a disk as somebody grabs the appliance and walks out with it, right? So we worked really hard on building a zero trust solution there, and then making it stateless really makes it very easy to manage, right? So we get, if I need more workload, I just install another one, right? Either a piece of hardware, another VM or a container, just install another one, and because you don't have to maintain communications between them, they don't have to be aware of each other. If one drops out, the work just keeps going, right? It doesn't need any kind of state management there.
Yeah, one thing just I want to talk before we wrap this up will also be, you did touch upon it initially when the project was created, but I also want to understand how important is open source, not only for the group, but as you also said, initially, because in today's world, a lot of things are moving in a as a service format, where in early days, you do come back from those days where you're distributing, as you mentioned, you have to give away the source, but that also depends on, whether you look at the 4 definitions of, Free Software Foundation, unless until you're distributing the code, you don't have to give source code away. But when you're running the code in your own server and you're offering it as a service, you're actually not distributing anything. And that's why a lot of people, they start, cribbing or complaining about, and they're looking at other changing the licenses. How do you see, what kind of future you see of open source in today's world?
That's a good question. So I think the values that are around the open source right now, there's a few of them, and a couple of them really specific to monitoring. So when you're a heterogeneous monitoring platform, you're not tied to one specific technology or vendor. It's hard to build a lab for your software that's going to test the solution against every type of technology that's deployed or offered to customers or users from the hundreds of thousands of vendors out there. And it's hard to test at scale, right? Because you just can't recreate these things in the lab. And I think that's really, to me, I've been using this term, I was like, a lot of OpenNMS is forged in the fires of open source, where people really put it to the test and can test it against a myriad of equipment and technologies out there. And we wouldn't be able to create a lab like that for ourselves. And then the open source nature of what I think open source also adds is this collaborative nature, right? So, as if you look at the open source project today, it's like, I used to know like what bug number we were on, right? Like there's like tens and tens of thousands of issues that have been created in our Jira project that we keep public. And so much feedback comes from the community and so much input comes from the community. It's really hard to imagine that we would even have a user experience team that would be able to talk with this many people. And so we have kind of insights in not just from different technologies, but different ways that it's being used, right? And so that's one of the challenges that we have, is like, it's just so many ways we've adapted the platform based on users' inputs, is that it's really hard to keep that, all those adaptations, moving forward with the product as we're changing and evolving over time. And I think open source, really isn't what it used to be, right? It wasn't about being able to provide copy protection. It was really more about an ecosystem for fueling this collaboration. And that's, I wasn't cognizant of it, but you could just see it as it was happening, with technologies like Kafka and Elastic and Kubernetes, being open source, these very large organizations providing stewardship over these projects that they saw really were going to, you know, probably eventually benefit them, in their own environments and in their own business models, but truly, changes the world, right? So how many chances does, in how many ways does the world change because of open source? I mean, we wouldn't have cloud today like we have today if it wasn't for, Linux, right? And you wouldn't have AWS, you wouldn't have Google Cloud. It would, I don't think, maybe we eventually would have, but it's just, I think it's really been what open source has done to change the world is what's really, I think, the most important piece there.
David, thank you so much for taking time out today and not only talk about the group or share the history and the story, but also how the group has evolved. Because when I talk to somebody who created, the company predates so many technologies, and today, every week, new technology from the CNCF comes out. So it's also refreshing to see, as you said, the core components are still being used and they will continue to be used, just like mainframe. No matter what happens, mainframe will still power the modern economy. So thanks for sharing all those insights, and I would love to have you back on the show. I really appreciate your time today. Thank you.
Yeah, thank you for your time. It's been my pleasure.